61, go.
Okay, so you remember, what lesson is this? 61. You remember we've seen what this is.
X.
Average.
Average. And if we're talking statistics, it has another name. It's called the mean, right? And you've seen the median, and you've seen the mode, correct? And there's this one. These are the names that you put when you have 30 or less number of data, okay? If you have 30 or more, actually more than 30, then it's called, the symbol changes, and it's called still the mean, but it's new. It changes the symbol. And there's going to be one more for both. One more symbol, which is, I think we already saw it, and that's the standard deviation. Remember? Remember the standard deviation?
No.
The standard deviation is the average, if I have to put it in words, it would be the average of the distance between the data and the mean for every single data. So for example, let's say that the mean is 3.5. And you've got, these are the numbers that you had. You had a 4, a 5, a 3, a 2, and another 5. The distance from here to the mean would be 0.5, right? And you square that. And then you do. The distance from this one to this one is 1.5, and you square that. And so on. And then you divide. You remember this? We saw this.
No,
I'm sure we did.
Yes, we did.
No, it's here. It's here. It's the first time. I'm sorry. Okay, so I have to do it slowly. My bad. So first we're going to do something called the variance. Is it clear what the average is? The average is if you take everything into one big pool and then you give out equal amounts to everybody, right? So the variance is if how much each of those things in my big pool lost to the pool. Does that make sense? Because the average is 3.5 and this one, guys, don't work now because this is new and I don't want to explain to you. Just saying. So the distance from, I have 5 pieces of data. And how much did this one give to get this average? This one gave 0.5, okay? So this would be 4 minus 3.5. How much did this one give?
5.
1.5.
5 minus 3.5. This one gained, right? 3 minus 3.5. This one gained also. They don't explain it like that in the book, but over years, trust me, that's what I've come to understand, okay? So, that would be, and you would divide all of this by, how many did you have? 5. So you would find the average of how much each one gave. Does that make sense? Gave or gained. And that's called the variance. And since you're gonna have negatives, and that would make it all weird, that's why we squared. And that's the variance, okay? Without the squares, just this is called the deviation. Why? Because it deviates from this mean. There's a term in statistics called measurements of central tendency. Do you understand what a tendency is? I have a tendency to get angry, for example. That means that I have a pattern that I've shown over the years, and you can infer from that pattern that probably if you don't do something, I will, since I tend to get angry, I will probably get angry if you do something. How do you translate that to numbers? If there's the students of equity tend to have high grades, right? I see the history of how much the grades have been in the past 10, 15 years, and they're all above 85. So I can infer that the tendency is that they're going to have high grades, right? The measures of central tendency are these. Why? Because you tend to make like a line in the middle to see how things behave according to a certain norm or according to a central tendency. It tends to be like that. We'll see right now that you can have a normal tendency, and that's where it comes from. What does the norm do? What does almost everybody do? This, and then there's the outcasts on the sides, but everybody tends to do things. So that's why you have the measures of central tendency. Remember that the median is which one is smack in the middle position. This one, you average everybody out. You make it centered. And the mode is which one repeats the most. But it's still a thing of central tendency. So, when we look at the deviation, it deviates from this one. Does that make sense? Hence the name. The variance is this one. And then you standardize it by, if this is the variance, this one would be the standard deviation. Have you noticed that as we get closer to the 21st century, society tends to standardize everything. Everybody should have the same. That started during the 1800s. Marx, Engels, they all started to standardize everything. Everybody should have the same. Everybody should go to school. Everybody, they're standardizing. It's a school of thought, and that's where statistics started to get its whole thing. The standard deviation is, what if we make it the same for everybody? So what they did is, they took the variance and they square rooted, since you had all the squares, well, what would be the inverse of the squares? Square rooting. So even though mathematically it's not direct because you have additions, it's the standard deviation is the square root of the variance. Okay? Does that make sense? Now, what do you use the standard deviation for? And this is where it gets nice and fun and long. I think we're going to have to do this. If we don't finish it today, don't worry, I'll continue tomorrow. And you can play with the blocks another day, okay? Because this one's a long one. Let's do a part 2, okay?